All right, good morning, everybody. My name is Leo Larios-Schmidt, and I am the Applications Engineer for C-Motive Technologies. And as mentioned, today I'll be talking about our latest motor development, ZeroMag, and our electrostatic motor systems that we've been developing. Perfect. So who is C-Motive? C-Motive is the world's only electrostatic integrated motor drive. We create torque without the need for a gearbox or magnets, allowing us to deliver the lowest operating cost of any motor. A few quick facts about us. We're located in Madison, Wisconsin, home of UW-Madison, where our technology originates, which is electrostatics. We have a team of over 30 people working on this project, and we've had 20 domestic and international patents that have been awarded to us. Today, I'll be talking about the history of electrostatic motors. I'll be introducing ZeroMag and how the technology really works. And I'll be talking a little bit about the competitive advantages of using ZeroMag. So what is the history of electrostatic motors? It all starts with Ben Franklin, roughly 275 years ago. Franklin develops what is known as the Franklin wheel, and he uses these Leyden jars that are charged, and he charges thimbles on the end of these glass rods that then spin on this shaft. It's not a lot of torque, and it doesn't go very fast, but it does use the basic principle of statics to turn a shaft. So we call it the first electrostatic motor. Unfortunately for Franklin, the understanding available to him in his time really limits where he can go with this. So he kind of stops developing this. He just keeps it as a small experiment, and he moves on to something else. From there, MIT picks up electrostatic motors 95 years ago. Unfortunately for them, they are limited by the power electronics and controls available to them. And if we fast forward to 50 years ago, GE completes paper studies on what an electrostatic motor could look like. They conclude that the liquid necessary to go between the gap distances would not work. Well, thankfully, C-Motive comes in 10 years ago and creates its first electrostatic motor. With the understanding and technological improvements since Ben Franklin's era, the development and capability of the power electronics and controls that have happened since, and with the development of our own proprietary dielectric fluid. So over the last 10 years, C-Motive has been hard at work. From that first initial motor, we've put a lot of effort into the development of this. The early motor iterations allowed C-Motive to understand understanding and using electrostatic forces to generate torque. And we've tested several different product sizes and strategies along the way. Our first motor that we really use for development is what we're calling the Alpha platform. And this is really our proof of concept motor. This is a single pole stepper motor that uses two medium voltage connections here. And what this really proves is that we can use electrostatics to align a rotor to a stator. And originally this motor was made with hand-cut aluminum plates that were later replaced with PCBs. And if you can tell, this housing is actually made out of plastic, something that we eliminate in the next iteration. So this becomes known as the beta platform. And what we use this motor for is for charting our course. With this motor, we are able to better understand where we need to go, what our niche is going to be in the market. And part of that process is developing this multi-pole AC-DC technology. So instead of using the two in the original, now we have 5 medium voltage connections. As I said, we've upgraded to the aluminum housing. And this really helps determine the best size and application fit for our technology. We are able to narrow our focus on stationary, low-speed applications. And from there, we go to the Gamma platform. And this has really become our field-capable workhorse. This motor has been used internationally and domestically for demonstration purposes to prove how the technology works and to show customers really that it's not just an experimental project coming out of university, it is a real product. One of the big developments here is that we have moved into a multi-pole AC-AC motor technology here, and we've improved our medium voltage input to a single connector on the back end. And a couple of tests that we were able to do with this motor is this temperature testing. So in one of our demonstrations, they had a 1 horsepower IE3 rated gear motor that had been operating for several hours, as shown here. So after a few hours, it's heated up to about 108 degrees Fahrenheit. That's capable of burning you if you touch it by accident. Well, we replaced it with our motor. In the same application, running in the same speed, after several hours, our motor has only heated up to about 77 degrees Fahrenheit. And that's fully due to the elimination of a lot of the losses, allowing our motor to stay cooler as it operates. Another test that we're able to do is this sound test through a ramp up and slow down. And you can see that over here, the average acoustic noise that's being measured off the motor is sitting at around 60 to 65 decibels. So on the next slide, I will introduce ZeroMag and what the newest development of this technology looks like. So ZeroMag is really an all-in-one integrated motor drive. It is designed for large-scale manufacturing and assembly and is capable of producing 60 Newton meters, comparable to a 1.5 horsepower machine. This is ideally suited for low-speed applications. So you're probably wondering, how does this work? What is electrostatics? It doesn't make sense to me, right? Where are the magnets? So the way that it works is we have rotating electric fields that are created when voltage is applied to the surface of printed circuit boards, which are separated by an insulating dielectric fluid that helps magnify the field strength to produce torque. And that's really all it is. And it all starts with the motor drive. C-Motive has a multi-level topology drive that is unique design delivering medium voltage for 1.5 kilowatt motors. We utilize silicon carbide MOSFETs to help shrink the size of our drive so we can put it onto the back of our motor. And we use this because it's become cost-effective in the last few years. Because this is an electrostatic motor, we use charge-oriented control instead of field-oriented control. And it'll come with industry-standard communications, such as a dual-port Ethernet IP. And it'll come with 2 input voltages of either 240 or 480 volts AC. Then we go to the printed circuit board plates. Torque is created by applying voltage to the conductive surface of these printed circuit boards. Because the only copper that we use is on these printed circuit boards, we're able to significantly reduce the amount of copper needed to create torque. The rotor stator pairs are stacked within the motor with traces on the front side and on the back side. And we create torque by manipulating the phase angle of the 3-phase waves on the plates. This enables us to create torque at 0 speed. And then we have the dielectric fluid insulating those plates. C-Motive's proprietary dielectric fluid is the key enabler of electrostatic motor technology. It is a blend of commercial off-the-shelf solvents that we then blend to create a polar dielectric that augments that electric field. The fluid is safe to touch, which means that it is safe to touch and we can ship it internationally and domestically, but it is not safe to drink. I would not recommend doing that. So this all comes together into our mechanical design. Because we have a fully fluid because we have a motor that relies on fluid, this is a fully fluid sealed motor. Our case and shaft lock in the fluid using O-rings and lip seals. And this motor is specifically designed to keep maintenance as simple as possible. It has one wear item, which is the slip ring on the back end, which is easily replaceable just by removing the back plate. And another unique characteristic of our motor is that we have a removable and customizable shaft. And what this enables is we can eliminate the forces that are applied from the load onto the motor itself. So what is the competitive advantage of using this motor? What can this really allow us to do in the market? Well, as we know, electromagnetic motors rely on the torque constant of the motor and the current flowing through it. Similarly, the electrostatic motor relies on the Cm value, which is intrinsic to the motor, and that's more aligned with the capacitance of the motor. But because we are using voltage squared here, that really enables us to create a lot of torque based on the amount of voltage that we can put onto this. Typical constructions of electromagnetic motors, as we all know, are copper windings, the electrical steel, and permanent magnets. When we look at the electrostatic motor, it is really just the printed circuit rotors and stators, the aluminum housing, and the dielectric fluid. Drive technology, typically for electromagnetics, you can use CSI or VSI. And with electrostatics, we've shown that multi-level drive is really the only way that we can accomplish this in a small form factor. For the simplified circuit models, we know that with electromagnetic motors, there's a lot of copper winding losses and some losses in the electric steel. When we look at the electrostatic case, because we eliminate most of our copper, our RS term is pretty small and minimal, especially when compared to the RP term, which is the resistance of the fluid, something that has significantly improved in the last couple of years. So the key advantages here are that we don't need a gearbox to operate at low speeds. And this is really important because our customers don't like the leaking or replacing fluid or lip seals on these gearboxes. So this really limits the amount of downtime that they are required to maintain. Because we don't need a gearbox, our motors are more efficient. These gearboxes oftentimes come with 50–60% efficiencies, which even though the motor is pretty efficient, really limits the system efficiency overall. Because we eliminate the gearbox, we have that higher efficiency. And another thing that our customers really like is that they don't have to keep track of gearboxes. They don't have to keep inventory on them. And the second key advantage, as we've been talking about these last couple of days, is that there is a significant reliance on critical materials for most of the motors in the marketplace today. You can see here the rise in copper prices and neodymium prices and some of that volatility. And because we rely so much less on copper and don't use any rare earth magnets, this is really something that enables us to keep a stable price and be competitive for that. We also think that because we don't rely on these things, we can create a fully domestic supply chain as we scale up our efforts. So as you can see here, ZeroMag does become very competitive when we look at things like the necessity for a gearbox, the amount of copper used in their motors, and rare earth metals in particular. With a motor that is specifically designed for low-speed applications, we can really hit a high target out of efficiency here. So ZeroMag really delivers a full package of benefits without the need for a gearbox, without the need for magnets, and with a 95% reduction in copper. We are able to deliver the lowest energy cost. And a couple of benefits that our customers really enjoy is that ability to safely touch these things even after they've been in operation for, several hours. And with the improvement of our drive technology, we really believe that this generation will be the lowest, will create less noise, making a better industrial environment. And that's all I have for you today. So if you have any questions, I'll take those. You can also email me at this email, and if you go to this QR code, it'll take you to the C-Motive website. You can find us on LinkedIn and YouTube as well.